Is the numerical sections. Radius of the atom, velocity or energy of the electron. Second part we are dealing. What is the angular velocity of the electron occupying second orbit of the lithium dipositive ion? So here I have calculated this value. So angular velocity is equal to r into omega. So here Rn is equal to n square h square 4 pi square m e square j into k, and velocity of the nth orbit is 2 pi z e square k divided by n into k. So just put this value r here, v this here. So this is your v and this is r, n square h square 4 pi square, so m e 4 z k. Putting the value of here r here, this value here into omega, so omega equal to this much value. So here if you put the value of z equal to 3, n equal to 2, so here you will get omega equal to, so this will be your n pi square mp4 k square by h cube. So this is our answer of this question. So this is our actual answer D, 9 pi cube mp4. The answer is this. The velocity of an electron in excited state of hydrogen atom is 1.093 into 10 power 6 meter per second. What is the circumference of this orbit? So this is the velocity of nth orbit is given 2.186 into 10 power 6 into z by n. So this is the velocity of nth orbit. It's given here 1.093 into 10 power 6 equal to 2.186 into 10 power 6 into z is equal to 1. So 1 by n. This is for the hydrogen atom. Now circumference of the orbit is 2 pi r. This is circular orbit. So equal to n into lambda. So and the second, this is the first equation. Second equation is lambda equal to h by v. So h by v. So here from here we will find this one. So r equal to radius equal to 0.529 into n square by z. So from here putting the value of n, so n is this side. If you put this value of n, you will get here so now n is given here 2. So from here we will get 2. We're solving. So on solving here we will get n equal to 2. So this will be your 2 into 2 4 square z equal to 1. So this is the r. Now circumference of the orbit, that is 2 pi r is given here. So right here 2 pi r. So value of r we know that. So circumference of the orbit 2 pi r, r equal to here 4 is given here. So 2 pi and r equal to 0.059 into 4 into 10 power 10 angstrom. So on solving you will get here 13.3 into 10 power minus 10 meter. So this is our answer. A beam of a specified kind of particles of velocity v 2.1 in 10 power 7 meter per second is scattered by a gold z equal to 29 nuclei. Find out the specific charge of this particle if the distance of the closest approach is 2.5 into 10 power minus 14 meter. So distance of closest approach means when alpha particles come closer to the nuclei. So at that time potential energy equal to kinetic energy. So this is the kinetic energy. Kinetic energy equal to potential energy. This is the formula of kinetic energy. Half mv square equal to k into q1 into q2 by r. So q2 by m we need to find out q2 by m. Then put the remaining value rv square 2k into q1 into, this is your 2. It is 2 q2. This is q2 by m. If you put here, so it will be r. So this will be 2. So again substitute the value q2 by m. So this is the value 2.5. This is distance of closest approach 2.1 into 10 power 7 whole meter square. So already given here. This is the velocity 2 into this value 79 and into this is the, I think this is the value of z. So z equal to 79 into 1.6 to 10 power minus 19. So every value is given here. So putting the value you will get this specific charge of the particle which is coming to the nucleus. So this is our answer. So an alpha particle having kinetic energy 5 mega electron volt falls on a copper foil. What is the shortest distance from the nucleus of copper to which alpha particle reaches? Atomic weight of the copper is 29. Number is 29 and potassium. This is the value of the k is 9 to 10 power 9 Newton meter square c square. So again same thing, kinetic energy equal to potential energy. So we are putting the r value here. This is the value 9 to 10 power 9 into 29 into 2 into 1.6 into 10 power minus 19. This is electron square. 5 into 1.6 into 10 power minus 19. This is again the charge of the electron into 10 power 6. We have to find into electron volt. So this is the value of given electron volts. So if you solve it, you will get here 1.67 into 10 power minus 14 meters. So this is our answer. That is the shortest distance from the nucleus of the copper to which the alpha particle reaches. So calculate the value of A, that is A equal to E 1 comma 2, and this is second is equal to 2 into E 2 1, where E and Z. So energy of the electron in nth orbit, and Z is the atomic number of the hydrogen-like species. So here we can write here A equal to E 1 comma 2 and 2 into E 2 comma 1. So putting this value, minus 13.6 into 2 square multiplied by 2 square and divided by, this will be a 2 into 1 square multiplied by minus 13.6 into 1 square. So this we will get here 16 by 2. So answer will be your 8. So this is the 8. An electron in an atom jumps in such a way that its kinetic energy changes from x to x by 4. What will be the change in kinetic potential energy? So again we know that potential energy is equal to minus 2 into kinetic energy. So if potential energy is, if kinetic energy is the kinetic energy is x, so this will be your kinetic energy is equal to 2 into potential energy. Okay, so kinetic energy is given here x, first case. So this potential energy will be your minus 2 into PE. A second case, so if kinetic energy is given here x by 4, then potential energy will be here, not here, you can write here 2 into x, then potential energy will be here minus 2 into x by 4. Now they are asking change in potential energy. So change in potential energy, so change in potential energy will be your minus 2x by 4, and this will be your minus into minus 2x. So this will be total minus 2 by 4x plus 2x. So this will be total equal to 3 by 2 into x. So this is our answer. The number of revolutions per second round the nucleus in third orbit of hydrogen. So here number of revolution per second is equal to un divided by 2 pi into rn, that is u1 divided by n into 2 pi rn into n square. This is given here. So on solving, 2 point value of n is given here 2.8 into 10 power 6, and we can write here this is your n cube. So n cube will be your 3 cube minus 6.28 2 pi multiplied by r is 0.52 into 10 to the power minus 10 meter. So on solving you will get here 2.18 into 10 to the power 18. So 10 plus 6 will be not 18, this will be 16. 6 plus 10 16, and this will be your 27 multiplied by 6.28 into 0.53. So this is here 0.53. So on solving you will get here 2.44 into 10 to the power 14. So this is the number of revolution per second. Calculate the alpha particles of 6 mega electron volt are scattered back from a silver foil. Calculate the maximum value. So you calculate back the value. VAL value is in a volume. This is not value, this is volume. This is the volume, VOLUME volume, in which the entire positive charge of the atom is supposed to be concentrated, and this atomic number of silver is given 47, K is given this value that we know very well. So first we find the volume. To find we require radius. So energy is given here 6 mega electron volt. So right here energy is energy is equal to K into ZE into 2E by R, or we can write here K into 2ZE square by R. So energy given here, so right here energy is 6 into 10 power 6 already given here, 1.6 into 10 to the power minus 19, and this will be value 9 to 10 power 9, 47. So into 2, and this is into 2, okay, and again 1.6 into 10 power minus 19 whole square and divide by R. So from here R value of R will be equal to 2.25 into 10 to the power minus 40 meter. Now for maximum volume, this we need to find out. So maximum value equal to 4 by 3 pi r cube. So we know the value of R. So 4 by 3, 3.14 multiplied by 2.25 into 10 to the power minus 40 whole cube. So we'll get the value of R, that is volume, that is 4.8 into 10 power minus 41 meter cube. So this is our value of, that is the value of the volume. Calculate the angular velocity of an electron occupying the second Bohr orbit of the helium positive ion. So here again velocity of the helium positive ion is 2 pi, that is z divided by n into h. So this is given here, and again z e square equal to 2 pi nh, and this radius of the helium positive ion equal to n square by h square 4 pi square m e square by z. And one more thing, omega equal to velocity by r. So on solving we can put this value v by r on keeping these values, it becomes 8 pi q z square m into e to the power 4 and divided by r, that is n cube into h cube. Okay, n cube into h cube. So now we can substitute this value. So on substituting we will get here 8 into 3.14 q, this will be your 2 square, so this will be 9.1 into 10 power minus 28, whereas the weight of the electron multiplied by 4.8 into 10 to the power minus 10 whole power. This is the charge of the electron in ESU. N cube is 2 cube and multiplied by h is equal to 6.626 into 10 to the power minus 27 whole 3. So on solving we will get answer 2.067 into 10 to the power 16 second. The angular momentum of electron in hydrogen atom is proportional to, so there we have 4 options. We have to find which of the option is correct. So angular momentum is equal to m into v into r. Okay, and from Bohr theory we know very well, that is k into z square by r square equal to mv square by r. This is very well, centripetal force equal to electrostatic force. So from here we can find k z e square by r square, so multiplied by m r square. Here you write here mv square by r multiplied by m r square. So on multiplying we will get here, this is the nothing but the m into v square into r square, and this will equal to k into z square into m into r. So this is nothing but the angular momentum. So this will be your k into e square into m into r. So we can write here, this is L is given here, so this will be square root of m into r, so L is proportional to square root of r. So answer will be your C. So C is our answer.